Today we have 3.4, the present value of annuity and amortization. So last class, we were given the future value of an annuity, meaning if we make payments every month, every year on schedule, we'll have X amount of money in the future. Now, what amortization is let's say we bought a house or a car. How long is it going to take us to pay off this car, pay off this house, or pay off some type of loan? So this is what today is about. Okay. So here are the formulas for amortization. PV, present value, is equal to the payment times 1 minus 1 plus I to the negative n over I. And then payment is equal to present value times I over 1 minus 1 plus I to the negative n. And if we have to solve for time or compoundings, then the last equation is n equals the natural log of the payment minus the natural log of the payment minus present value times I over the natural log of 1 plus I. Okay, so PV is, of course, your present value. Payment is your payment. Remember that I is your rate over compoundings, and N is time times compoundings. Okay. All right, so this page, we're just going to practice using the formulas, which means I'll get a calculator out. Let's see, there we go, there we go. And I just need a regular calculator. So just go back here. Scientific. Okay. So example 1 says n equals 40, I is 0.01, payment is 400. What is the present value? So we just plug those into the present value formula above. So we'll get PV equals our payment of 400 times 1 minus parentheses 1 plus I, which is 0.01, raised to the negative n, which is 40, all over our value of I, 0.01. Okay, so we plug in the pieces, and now all we do is calculate. So just like I wrote it, 400 times 1 minus parentheses 1.01 raised to the negative 40 over 0.01. Whoops. 1. There we go. And we get $13,133.87. Maybe even 88 if we rounded. But let's just say 87. Okay, cool. Okay. Next one, it says present value is 14,000, N is 72, I is 0.0005, and payment is what we're looking for. So we're going to use the second equation above for payment. Okay. So we'll get payment is equal to present value, which is 14,000 times, I can do that too as well, times, and it's going to be I, which is 0.005 over 1 minus 1 plus I, 0.005, raised to the negative 72. Okay. And now just plug in the calculator, just as I wrote it. 14,000 times 0.005 over 1 minus parentheses 1.005 raised to the negative 72. and we get the payment is going to be $232.02. All right. And third example. Present value is 20,000. I is 0.0175. Payment is 500. We are looking for N. So we're going to use the third equation at the top of the page. Okay, so everything's labeled for us. So we're going to get N equals the natural log of the payment. So natural log of 500 minus the natural log of the payment. Oops. Sorry. Natural log of payment, which is 500, minus the present value, which is 20,000, times I, which is 0.0175. All right. And then we put that all over the natural log of 1 plus I. And calculate. Again, just as I wrote it. So start our fraction and then function natural log of 500 minus the natural log of 500 minus 20,000 times 0.0175. Close that, come down, and again, natural log of 1.0175. There we go. And N is going to be 69.39, but there's that 8 on the end, so it's going to be 69.40. All right. And that was just practicing plugging into the formulas. Any questions on that?
No, sir.
All right. Let's get into the word problems then. Okay. 4. American General offers a 7-year ordinary annuity with a guaranteed rate of 6.35% compounded annually. How much should you pay for one of these annuities if you want to receive payments of $10,000 annually over the 7-year period? All right, so we want to receive payments of $10,000 over 7 years. All right, so this means we're looking for a present value. We want to know how much money should we pay for this annuity in order to get these payments of $10,000. Okay. So let's list everything we have. I'll zoom in, and it says we offer a 7-year ordinary annuity with a guaranteed rate of 6.35% compounded annually. Okay, so this means that we can find I and we can find N. So let's go ahead and find I first. I is rate over compoundings, and we're given a 6.35% rate, which is 0.0635 over, and we are compounding annually, which means 1. So we get a nice decimal number of 0.0635. Okay, and then we can find N, which is compoundings times time, and we are compounding annually, and we're doing this for 7 years. So N is just 7. And then the last piece is we want to receive payments of $10,000. So payment is 10,000. Okay, Cool. So we have I, we have N, we have payment. So we can now plug into our present value formula, which I'll do over here. So present value is going to be equal to 10,000 times 1 minus 1 plus I, which is 0.0635 to the negative N, which is going to be negative 7, all over I, which is 0.0635. All right, cool. And then present value, we just have to type this in the calculator and we'll get 10,000 times 1 minus 1.0635 raised to the negative 7 all over 0.0635. And in order to receive $10,000 payments over a 7-year period, we need to put down $55,000, 135.98. So we need to front that money up front, and in 7 years, we'll start receiving payments of $10,000 for this annuity to be paid out. All right, cool. All good on that one?
Oh, yeah.
Okay. 5. E-loan offers a 36-month auto loan at 9.84% compounded monthly to applicants with fair credit ratings. If you have a fair credit rating and can afford monthly payments of $350, how much can you borrow from E-loan? What is the total interest you will pay for this loan? Okay, cool. So let's go ahead and write down what they're giving us. So they're offering us a 36-month auto loan at 9.84% compounded monthly. So once again, we can definitely find I and N. So I is rate over compoundings, and the rate is 9.84%. So 0.0984 over, and then we are compounding monthly. So that's over 12. Okay. And let's see if that's a good decimal number. 0.0984 over 12, and it is. So we'll use that, 0.0082. Okay, and then N is compoundings times time, and we are compounding monthly, so 12, and then we're getting a loan for 36 months. So actually, this gave us N already, because time must be in years. So we know that 36 months is 3 years, and we get 12 times 3, which is 36. So we actually had N already. Okay. Then next is payment, and we want to see if we can afford monthly payments of $350. So we have I, we have N, we have payment. So let's go ahead and find present value, which is what we're looking for. Guess I could put that there, present value. Okay. So PV is going to equal 350 times 1 minus 1 plus I, which is 0.0082 raised to the negative 36 all over I, 0.0082. Okay. And then PV, let's see what we get. 350 times 1 minus 1.0082 raised to the negative 36 over 0.0082. And we want to borrow $10,872.23. And in order to borrow that amount of loan, we need to be able to afford $350 payments. Okay. But then it says, how much interest will you pay for this loan? Okay. Well, if we can get this loan, our interest, let's see. So to find our interest means we're going to do $350 payments for 36 months. So 350 times 36. So we are going to actually pay $12,600 for borrowing $10,000, almost $11,000. And yes, that's how interest works. You'll never pay back the original amount unless you pay it off faster. Okay. Or you just pay it off all at once. What we're going to do now is subtract the loan amount, which is 10,872.23. And this is how much interest we're going to pay. 12,000, oops. Minus 10,872. And we're going to pay 1727.77 extra in interest. All right. That's not bad. Usually, if you're borrowing money like a credit card, you're looking at like 20% interest, maybe more. All right. All good?
Yes, sir.
Okay. All right. 6. If you buy a computer from the manufacturer for $3,500 and agree to repay it in 60 equal installments at 1.75% interest per month on the unpaid balance, how much are your monthly payments and how much total interest will be paid? All right. Well, these problems are nice because they're giving us I and N already. Okay. So let's go ahead and write those down. So I, the interest rate, it's already telling us that we are going to pay 1.75% interest per month. So they already did the math for us. So this means our interest rate is 0.0175. And then they also figured out N for us. So N is the amount of times we're going to make this payment. So we agreed to repay this computer back in 60 equal installments. So N is just 60. Okay. And then what we know is that we're going to buy this computer. So the present value, we're going to buy this computer for $3,500. So the one thing we want to know is how much will our payment be? Okay. Which means we can go ahead and plug this information in and solve for payment this time. So payment will be 3,500 times And the payment formula is going to be I, which is 0.0175 over 1 minus 1 plus 0.0175 raised to the negative 60. And we'll get payment is equal to, and let's see, 3,500 times 0.0175 over 1 minus 1 plus, actually, that's just 1.0175 raised to the negative 60. And if we buy this computer for 3,500 at the agreed interest rate, and for 60 equal installments, we will be paying $94.69. That's not bad for computer payment. It costs that much. Okay. Last part of this question says, again, how much interest will be paid? Well, we're going to make payments of $94.69 for 60 months. So $94.69 for 60 months. Oh, goodness. So this means we're actually going to pay $5,681.40 for this $3,500 computer. So subtract 3,500. So that's easy, right? No calculator. So we will pay 2,181.40. That's how much extra we will pay in interest. That could buy us another computer. So that is why you just don't make the minimum payment, right? You always put more in so you don't pay that much interest. But being a college student, it's hard to go over the minimum payment. Okay. All good on that one?
Yeah, clear.
Yeah.
These last couple weeks, just all your math lines up with my financial accounting class. It's making both a lot easier.
Hey, that's good then. That's good to know.
I might actually be learning something.
Well, especially in this chapter. This is chapter 3, all about money. Everything else we teach was algebra.
Yeah.
All right. 7. You want to purchase an automobile for $28,500. The dealer offers you 0% financing for 60 months or a $6,000 rebate. You can obtain 6.2% financing for 60 months at the local bank. This is if you choose option 2. Which option should you choose? Okay, well, let's explore our options. Option 1 means we'll have no interest and we will, what is it? We'll have no interest for 60 months. So that means that for option 1, our payment is just going to be the amount of the truck over 60. And if we choose this 0% interest, our payment will be $475. That's option 1. Okay, but now let's look at option 2. Okay, so option 2, we're buying the automobile for $28,500. So here's present value. We're buying it for $28,500. And then we're going to go to our bank and obtain 6.2% financing for 60 months. Okay. So this means that if it's months, then we're going to have rate over compoundings. So we're going to get 0.062 over 12. Now, is that a nice number? No. So we're going to leave it as the fraction. And then we're going to be doing this for 60 months. So they're giving us N. N is 60. Okay. But if we choose option 2, then the dealer is going to give us a $6,000 rebate, which means we're not paying $28,000 for this car. We're actually paying $22,500. And that already seems like a deal because they took $6,000 off, right? So now all we need to find out is what will the payment be? So payment is going to be 22,500 times our interest rate of 0.062 over 12 over 1 minus 1 plus 0.062 over 12 raised to the negative 60. Okay. And type it in. 22,500 times 0, need another fraction up there, 0.062 over 12 over 1 minus parentheses 1 plus fraction 0.062 over 12 raised to the negative 60. And if we go with option 2, our payment will be $437.08. There we go. So who has the better deal? I don't know. Let's see. Right. You'll pay back 28,500. And then here, 437.8 times 60. Yeah, you still better deal with option 2. Because even with your interest rate, you'll pay back in total 26,268. So it's still definitely less than the 28,500 with the 0% financing. So don't fall for the trick, right? Okay. Next one. A time machine cost $80,000. You pay 10% down and amortize the rest with equal monthly payments over a 7-year period. If you pay 9.25% compounded monthly, what is your monthly payment and how much interest will you pay? All right. So let's put together what we know. First off, the present value of our time machine is $80,000. But then we are going to pay 10% down. So we know that 10% of 80,000 is 8,000. So here's our 10%. So we're going to be paying 72,000 for this time machine. Okay. And then we are doing this for 7 years and we are compounding monthly. So we can find n first. N is compoundings times time. So we are compounding monthly for 7 years. So that's 84 months. And then we can find I. We are getting a rate of 9.25%. So 0.0925 over 12. And let's see if that's a good decimal number. It is not. So we'll leave it as is. Okay, which means that we're going to buy this time machine and we're going to be looking for the payment, which means let's go ahead and plug it into the payment formula. All right, so payment is going to be 72,000 times I, which is 0.0925 over 12 over 1 minus 1 plus 0.0925 over 12 raised to the negative 84. Okay, there it is. And then payment, let's see. 72,000 times, get another fraction up there, 0.0925 over 12 over 1 minus parentheses 1 plus another fraction 0.0925 over 12 raised to the negative 84. And the payment for our time machine is going to be $1,167.57. Okay. Time machines are expensive.
Whenever you're putting your number of compoundings, is it always negative?
For this problem, it's negative. So by the formulas, it's always negative n.
Yeah.
Okay. Right? So for PV, it's 1 plus I to the negative n. And even for payment, you flip it over and it's still down below to the negative n.
Cool.
Okay. And then we want to know how much interest will we pay? Ooh la la. Let's see. So interest, we will be paying $1,167.57 for 84 months. And oops. Actually, let's just write that right below. That'll give us 98,075.88. And then we subtract the amount of the boat, which is 72,000 and 98075.88 minus 72,000. We will pay $26,075 in interest. Oof, that's a lot of interest. But hey, you got a time machine.
True.
Okay, all good on that?
Yes, sir.
All right. Then we are on the last, no, not the last one. Last word problem though. Okay. 9. Some friends tell you that they paid $35,118 down on a new house and are to pay $737 per month for 30 years. That would be nice. If interest is 5.1% compounded monthly, what was the selling price of the house and how much interest will they pay in 30 years? So we are going to solve for present value here. And then to find the original price of the house, once we find present value, we'll just add the down payment of 35,000. So let's go ahead and label everything we know. All right. So we know that we are making a payment of $737. And then I is R over M, and the rate we're getting is 5.1% compounded monthly. 0.051 over 12. Let's see if that's a nice number. 0.051 over 12, and it is. We get 0.00425. And then N is M times T. We are compounding monthly, and we are doing this for 30 years. 360 months. Okay. And now we want to solve for present value. So present value is going to be equal to 737 times 1 minus 1 plus 0.00425 raised to the negative 360 over I, which is 0.00425. Okay, so 737 times 1 minus 1.00425 raised to the negative 360 over 0.00425. And the original price of the house is 135,000. Not the original price, sorry. The present value after the down payment is $135,739.99. But if you round, we'd be at 740. So let's go ahead and do that. 740. Okay, so this is the price of the house after the down payment. What we want to know in this problem is what was the selling price of the house? What was the original price? So what we're going to do here is just add that down payment of $35,118. Okay, so 135,740 plus 35,118, and the original price of the house was $170,850. That is pretty good. Doubt you can find a house for that much right now. Yeah. We can't even draw W today. Oh, W. There we go. Okay. And then the last piece says, how much interest will they pay in 30 years? Okay. Well, let's go ahead and figure that out. Interest. We're making $737 payments for 360 months. So 737 times 360. Our house total payments will be $265, $320. And then we're going to subtract that from the price of the house after the down payment, because we owe $135,740. And 265,320 minus 135,740 will pay in interest $129,580. Interest is just the worst when you're borrowing money, but interest is the best when you're investing. Okay, cool. Any questions on that one?
No, sir.
All right then. Don't need the calculator anymore. We get into the last page. All this exercise is finding out what formula fits where. Okay. So we're given compound interest, we're given continuous compound interest, we're given APY, and then we're given future value and present value. Okay. So number one, Johnny wants to invest $4,000. Which is the better annual percentage yield? 8.1 or 8.1 compounded semi-annually or 7.7% compounded daily. So we're looking for an annual percentage yield, and we're given compoundings semi-annually or daily. So this is going to be F, the APY using compoundings. Okay. 2, a company wishes to save $1 million in 5 years. How much money should be deposited each month, assuming the company will receive a rate of 5% compounded monthly? So here we want to know how much to deposit each month in order to have a future value of $1 million. So this is going to be H, because we want to have an amount. We want to have $1 million in the future. Okay. 3, Roberto makes a one-time investment of $8,000 at 2.5% compounded continuously. How much is in the account in 12 years? So we are compounding continuously. So that's our best friend, PERT. So this is going to be E. All right. Candace is pre-approved for a 20-year mortgage of $165,000 at 4.875% interest compounded monthly. What is her monthly payment? This is going to be what we just learned. Present value, because we just bought a house, we just bought a car, we bought a time machine, and now we want to know how much our payments are going to be. So this is going to be I. Okay. 5, Josh repays a loan of $10,000 at the end of 10 months. What amount was repaid if the annual interest rate was 8.3%? Okay. So this is going to be, there's no compoundings at all. So this is just going to be our simple interest theorem. So this will be C. Okay. Then 6. Wes wants to invest in his children's future. He decides to deposit $1,000 every 3 months in an account paying 4% interest compounded quarterly. How much will be in this account in 10 years? So here we're doing $1,000 every 3 months. So we're putting $1,000 in every time in order to have a future value of some amount. So number 6, this is going to be H. Okay. And then 7, Kelly wants to buy a new car. Her payments are $465 per month for 5 years. Her interest rate is 2.9% compounded monthly. What was the total amount of a loan? And that's going to be under present value. So number 7 is going to be I. All right. And there we have it. So just know what formulas to use when you're working these word problems. Okay. And that is it for 3.4. So our exam is on next Thursday. So this Tuesday coming up will be a review day. And next Thursday will be our third exam.